I assume that's better. Can everyone hear me out there? All right. Well, good afternoon. Thank you for this time to share with you. Sweet Life Systems. It's an honor to be here with you, supporting your chapter. Seeing your online presence. You got a great looking group of folks there with your web page, and it's always fun to visit active and effective chapters. So today, we're talking about advanced monitoring ecosystems. We're going to get into some use cases and talk about things that you're probably already doing. And then we're going to talk about some more advanced applications. And the floor is open for questions at any time, so I encourage you to ask questions. We'll start. Let's see. We'll start by talking about who Sweet Life Systems is. We've been in the monitoring control business running on 25 years. We've got a large footprint doing transmitter remote control sites all the way up to hub applications for many of our clients, as well as studio management, power monitoring, facility monitoring, things of that nature. We do our own software development, and we are versed with systems engineering as it relates to this application. One news flash is at NAB, we announced a merger with another company, MNC Software. Sweet Life Systems with MNC Software is forming Leeward Software. With this, it's two companies with similar visions for monitoring control. MNC Software, their large footprint is doing all of the DirecTV sites across the globe. That's their large customer. On the television space, the Mosaic software is set up doing all of Ion television, their sites across their enterprise. And so together, they're similarly architected type solutions molded together to create a end-to-end workflow, if you will. We've been working with these guys for over 2 years now, and got some successful deployments that have been placed and some underway that we'll speak about a little bit. This is in the picture. That's my president, Nigel Brownett, and my other president, James, and I'm forgetting his last name. Still getting to know each other, so please bear with me. Enough about that. We'll get into advanced monitoring ecosystems, and what we're talking about here is the objectives of having a monitoring control environment. Your main functional objectives are to increase your visibility of operational information across your environment, whether if it's facility wide or if it's technology wise. Bringing all of that situational awareness to your attention, as opposed to you wondering what's going on in your operation. With this, when it's set in place, your overall operational efficiencies are improved by virtue that you've got things coming to you in either your phone or your screen, as opposed to you having to walk the halls to look for blinking lights every day and that kind of thing. And it helps increase the fault events responsiveness and elevate an overall operational confidence from one end of your environment to the other. And to enable this, features that are part of this, these benefits are being able to preempt fault occurrences. These fault event occurrences before they become a problem, know what's going on with varying levels of alerts and notifications, cautionary levels, and then it more or less know what's happening when in your operation, whether if it's facility or technology related. And then ultimately it's enabling a better troubleshooting and recovery ability in this environment when it's placed properly. So we'll jump into some use cases. We'll start with the remote site use cases. First one is RF power monitoring. This features the dielectric RF Hawkeye system, where it's used to monitor your power levels on the output of the transmitter to the antenna. When put in place, it can actually, it sends a sine wave up the line. And if there's a problem on the line that starts festering up, it can actually pinpoint where that problem is. The result of that is saving you thousands of dollars. I'm not sure if there's been any line burnout events in your market here, but they happen far and wide, and it's very costly when they do. So the idea is here that you integrate this specialized purpose-built monitoring system, the RF Hawkeye, into your central monitoring system, whereas you the Hawkeye is going to give you cautionary levels of VISWAR if they're too high. You can then use the monitoring system that's monitoring the rest of the site to either back down the transmitter or switch the lines to protect your investments. And really how this is deployed and how the monitoring system is engaged with this data from the RF Hawkeye is up to how you wish to use those data points, how you wish your system to respond. And it's really up to you, but all of it can be automated based on your defined parameters. Another use case for remote site monitoring, and this applies in the studio site as well, is power monitoring management. It's where you're taking readings of your incoming power, you're taking data off your generator, and generally you want to monitor the power off your ATS, make sure you're being notified if there's any changes there. So an automated operation with this allows you to change from one to the other. You can actually take weather data, incoming weather data as far as a storm of any type, and manage that data to turn the generator on before it hits, those kind of things. Make other changes as you see fit to prepare for the storm. And then, with this, a lot of these connections tend to be GPIO connected, depending on the age of your systems. Some of the newer systems, like the generators, they'll give you an SNMP or a Modbus type application you can pull the data points from. But a lot of it's a matter of using all of the different protocols to have everything connected to where those real critical systems are brought to your attention, and you've got a handle on what's happening. Another area where programming your cautionary levels. So if you get, a brownout or something like that, you don't need to be alarmed and everybody stop what they're doing on every particular alarm, but you program those to where you know what's happening when. If there's a trend or something happening, you can respond to it effectively. Another area where integrated monitoring management might occur remotely is where you've got analytical monitoring devices that are engaged or deployed to bring your data points to your attention. Integrating this with your local monitor allows you to set alarm thresholds to where if something is trending or if there's an occurrence that you need to manage, you can respond to it effectively. And this is really, this kind of integration is up to the local engineer of how he wants his data points to be operated. Some TV station groups require this kind of integration as well across the group, but this particular guy, he did all of this setup. As this, you can see his it's just partial screen of the what we call the OVI, the operator visual interface. This is where over COVID, he had a little bit more time to spend in developing this kind of screen. So, and largely that's what it takes is time and focus to do this type of integration. But it can make for a busy screen when you're bringing in that level of data points. I mentioned power management. That kind of rolls up into building management as a use case where, all your power management, your ambient temperature, humidity, dew point site conditions, strategically placed water sensors for managing any drops from heating and air systems or wherever that might come from. And then as well, deploying smart thermostats, bringing that all into a more or less facility management type application. And here, one point in this is that, systems that give you one screen, one consolidated management, being able to manage facility and technology are most helpful in that you're just looking to one place for your information as opposed to going to 4 or 5 different applications. So point that out. Being able to integrate disparate systems, an industrial protocol that's become a standard is BACnet. And it in itself is, a language unto its own, pardon me. But it can be integrated into or interfaced with Modbus IP type translators. And we've done that in some applications. So it's there are some tools out there that you can use to consolidate the languages for your monitoring system as you desire. And all of this, being able to capture reports, operational trends is real important for your operation. So, when you talk to management about needing a new UPS, as a friend of mine did with his monitoring system, he's down on the Gulf of Mexico in St. Pete, Florida. Radio operations got like 8 radio stations. The UPS, he knew it was going out. But to convey that to his general manager to make sure it was taken care of before it became a problem, he was able to use the monitoring system to show the trends and, to show what was going to happen. And, with the aid of the monitoring control system, he was able to get that budget passed with very little argument because all the facts were right there in front of you. So just a plug for the data that comes out of these systems. Another use case that is very important to your operation is the transmission from your studio site, whether it's radio or TV, for that matter, to the transmission site, the transmitter site, managing failovers, whether if it's fiber, STL, or a combination of all of the above. Being able to automate that is very helpful. Where you can know what's happening when on those paths. Many cases, auto changeover switches are put in place, but if you don't have that system connected, those changeover switches connected to a monitoring system, you may not know that they fired. And it's helpful to know what's going on with your operation as you guys know. So one use case to shore up an operation where there's 8 streams playing out. This client, we just recently deployed this system, which is the Mosaic, where you've got each one of the ACOs connected to the monitoring control, got the ability to the unit that that they've got deployed is the Atemi DR5000, which is an IRD changeover unit. It's a little bit unique, I guess, in that regard. It actually has a little stream that comes off of it that we could pull into this system, so you could get presence monitoring with this. And the drill down, I don't have that pulled up here. The drill down takes you to the any of the ACOs that is alarming, or that's giving you a notification that it's sent off. And there you can tell which stream, which encoder is active as well. You've got all the data points pulled up of the device itself. So just one idea. In this particular case, um, the long-term plan is to monitor and control all of the air chains in this operation, of which there are 8. And but to get things started, we connected the auto changeovers, the one area where he had no notifications and needed help. So, any questions on what we've talked about so far? We'll get into some more advanced applications for monitoring control, and this is where you've got different types of monitoring systems, whether they're IP probes or analytical monitoring devices, or it could even be like a compliance logging system, which is collecting a lot of data. We can integrate these systems into monitoring control and help you build out what we call a more manageable ecosystem for monitoring. So these types of applications are, much integration's done via SNMP, but there's push API type applications now that's more common, especially as it talks to integrating different software programs with each other. But a big deal going forward is where I think as a standard for broadcasters is to have software interoperability is real important. And being in the monitoring control, it's an opportunity where we can make a lot of that happen with our engineering and design teams. But essentially, these different systems are sources for alarms, and then a central NMCS, Network Management Control System, manages the alarm response with control as you see fit and design. So more or less, you've got a centralized data capture, fault management, embedded screens with into your monitoring control dashboard. You've developed, you can pull in these secondary applications to where they can be a part of that. You can more or less have one screen to look at when you need to. And then being able to dynamically manage the critical device failovers. We're talking about automation with configuration management, being able to test failovers. That's one thing to have a failover, but it's a better thing to have a failover to a device that's configured properly and to know what devices are available. So in a real busy production broadcast environment where certain devices, somebody's got different projects, they say, well, we'll just use this D to A or this A to D for this path. And, if there's not communications on that, somebody reaches for it to do like the evening news or something like that, potentially.
In that, I'm assuming there's a log you can go and check to see if.
Yes, sir. Yes, sir. Yes, and there's scheduling software, or there's asset management. There's a couple varying levels of how you can manage that information. Generally speaking, when you've got everything connected, the system's going to tell you what it's grabbing, if it's available or not. And so there's a scheduler built in. Of course, the trick is having the devices connected so you can maintain that information. But within this environment as well, one key thing is that you can change your layouts, source selection, and even control audio outputs and things like that. So there's a lot of power when you build this out. And we'll show you some use cases where we've done that. Yes, sir. Yes, sir. And you can have multiple different parts of this as well. Let me back up. This is what I was speaking of with what we commonly call studio management. This case where we're monitoring the air chains, each one of these represents a different call letter in this particular centralized application. And it's not necessarily a hub, but it's the operation within this TV station. And so being able to have all those data points, all the disparate managers, as well as as you know, going forward, a lot of IP-based connectivity. So not only managing routing switchers, but your network switches, knowing availability of bandwidth, and things like blade management and that kind of thing, needs to be a part of your plan and deploying these systems. And this is what kind of interface you can actually have, is where you've got, you know, a schematic view of the signal flow. And with automation and root cause analysis, you can actually look at which part of your chain is the problem, and you can get down to exactly what that root cause is. And there's a lot of logic that goes into this. And so you can actually, anything that's downstream from your root cause, you can nullify those alarms with fault management, alarm management rather. And you've got an alarm window down here at the bottom. These are all your devices in this particular display, with a thumbnail of your outgoing image. But essentially being able to, you know, have a good interface where you can drill down on the root cause and manage your alarm storms effectively is what is the best achieved with this kind of a application. And getting into, you know, integration with monitoring systems. What we're talking about here is an IP-based probe system that surfaces all of the varying probes you might have, whether if it's distributed within your TV station environment, or if it's across a network of TV stations, or your contribution chain, whatever that is. These probes can surface images and bring you alarms on several data points within that signal, whether if it's related to SCSI, closed captioning, loudness, black frozen picture, those kind of things. And integrated with the monitoring control system, we can actually take control of that kind of an asset and then manage the screen build out on how it's presented, and do an automatic startup of the monitor wall itself, managing just the data points that matter of an alarming condition. In addition to that kind of control, we can, you know, manage layout changes on the application of the multi-viewer. We can control the audio output, can update the under monitor display text. We can acknowledge alarms, and we can do overlays on top of that multi-viewer screen with dynamically control the monitored sources, changes the sources, and of course, this takes interfacing with router and multiple type device integration, but it can be achieved if this is what you need to do. You know, largely in this kind of thing, you know, especially me being the sales guy for monitoring control systems, I think it's very cool to have everything connected. But ultimately, it's what makes sense to your operation. You know, where are your starting points, and where are your priorities, and you know, where are any gaps that you need to shore up in your operation to grow into. But we'll talk about that a little bit more in a minute. Here's another application where the monitoring control system was in progress being deployed, and lo and behold, here comes COVID. And so now they have to manage the remote workforce. And in this instance, the Mosaic solution was called upon to help manage this remote workflow or workforce management dashboard. And so we created a universal console covering signal routing, master control, the multi-viewer. And it set up to where any user could request a console for their program, what they were responsible for. And this could apply toward, this was master control, but it could certainly work in production control as well. The orchestration capabilities are there. So it's a matter of what makes sense. And there's some levels of orchestration that can actually lay on top of this that we introduced at NAB, but we won't get into that. Anyhow, the monitoring control solution in this application was responsible for identifying the console, and it was set up where they sign in, and it knew by that person sign in what their program was. And so a lot of those things could come together without there, being a lot of clicking around and hunting and pecking and trying to find what's going on. But it would set the layout applicable for the program, the selected service, joining the console to multiple sources associated with the service for that program. So any questions? So additional application where monitoring controls used as a interface to manage across multiple sites. This is how Major League Baseball used Mosaic to interface with the Tag VS multiviewer. They set it up for monitoring feeds from across multiple stadiums and setting up an operational area where the user could gain control of the multiviewer, select active audio outputs, and do multi-view, the source switching to the multiviewer. And so this particular case, they were joining 4 output feeds to the control panel at a time. They had availability of all the different stadium feeds as they wish. A similar application like Nebraska Public DirecTV asked for selectable consoles for set up for their remote confidence monitoring. And this was set up to establish a trouble wall. So only things that were coming up to the multiviewer were problem events. And so the certain tag instances were reserved for this application. And then the Mosaic solution, the monitoring control system, would manage those resources accordingly. And so essentially it set up things being automated to where the trouble wall content was triggered internally by the Mosaic based on the alarms detected. So pretty powerful to think, your monitoring control can, instead of, there being a lot of troubleshooting involved in an event, all the data is bringing to you and you know exactly what's going on, then you can respond to the event more effectively. As well, they integrated this via API request into some other applications within their environment. So, to establish these kind of things, your monitoring control system have some key capabilities. The ability to integrate with the monitoring control platform and the ability to extend and modify features within devices, well-documented extension points for API integration. And this is real tricky business sometimes. We integrate with a lot of different manufacturers. Some of them are a lot easier to work with than others. And in many cases, when there's difficulties, we have to use the client's relationship with the vendor to hold leverage. And that's kind of natural. People are kind of closed in, but more and more open API integration sharing is more common. We've endured a few challenges over the years doing this stuff, as you can imagine. You'd probably recognize the vendors that are more difficult to work with than others. But so to do all of this, another key aspect is the scalability, where I think I messed that slide up. The bottom image was supposed to go away. So it's not your vision, it's my ineptitude on PowerPoint. I apologize. But a key aspect is scalability, being able to horizontally scale, where you've got capacity not only to work within your own environment. This is more important for, you know, the groups and the enterprises across campuses, and but the ability to scale to where you can manage hundreds of sites, thousands of devices. Generally speaking, I think for I heard him say the other day that for DirecTV, there's over, I think, 50,000 devices that are connected and being managed, which is quite a plethora, so to speak. So with all of this, you know, the questions to ask in considering this kind of technology and this kind of deployment, you know, it's a matter of understanding, you know, what are your most important to your business, the monitoring data points, the control monitoring data points. And then, you know, are there any gaps? Where are those? Where could you shore up? You probably already have monitoring systems of some sort in place. And those assets don't need to be removed. They can, you know, with a good level of extensibility, they can be integrated. So that's the best consideration. Then, you know, what's part of that plan? And then, you know, asking other questions on, you know, how you're going to operate, what kind of environment are you going to create? So, you know, you probably already have a fault event response plan. How can technology of this type improve that? You know, what are your goals and objectives for making better? And, you know, just getting into simple questions on who needs to get which alarms. How do you want to manage the severity levels of alarms to where you can understand certain things you don't want to be messed with, but you want to know about it? And what kind of tools are you given to manage that effectively? And then how do you want alarms to be presented? And to go with that, you know, who are your key operational stakeholders? So, you know, defining the roles, responsibilities as you move forward, especially when engineering considers pulling in operations to be a part of this workflow. And that's largely what you know, a hub application is a part of. You got, most cases, you've got operators that know very little about a TV station operation, but their primarily goal is to notify you when there is a problem, being able to point to a screen, having similar screens to where you can talk about the problems that are happening locally. So it's a matter of how do you want that to work is some of your design criteria that you need to decide. And with this, certainly Leeward Software is glad to help you get started. A lot of our starting points are just simply starting with a spreadsheet and calling out the different functional areas and then devices within that. And then really helping you understand, you know, gaining a collective understanding of the functional objectives. Ultimately, you know, just like any systems integrator that works for you, we would want to build something that's uniquely yours and set you up to where it's, you know, we give you the keys, you manage it and use it the way it works for you. It working the way we want it to work, odds are tremendous it'll never work the way you want it to work. So you got to manage that. Then we're ready to help you with, you know, budgetary plans and long scale. This tends to be, in most cases, a long track period, but you can do it in phases and all of that's manageable. But do it based on, you know, scalable plan based on your priorities is how we try to work. And essentially the goal is helping you develop your third arm. Our best clients, that's a term that I got from one of my clients, where their systems program, they've worked with it over the years and they've grown and they continue to tweak it to make it more responsive and for it to notify them the way they want with automations built in. And it's not the sophisticated level of control we're talking about. It's more of the basic, remote management, all the notifications coming too. But it's set up to where they tag it their third arm because they know what's going on. And they've actually got one screen in their studio environment that shows the nature of the operation. And so, there's a real busy environment where there's a lot of remote production, a lot of effort going on in projects and things, studio events coming into town with music production. And this helps them, the engineering group, which is, as limited more than it used to be, that staffing helps them really focus and support the business more effectively. So. Pardon? It is. But it can start on with assets you may already have. These systems take time. I call it a to it technology because the time you give to it is when you can afford to get around to it. And the best systems I've seen deployed, there might be some person in that organization that doesn't have as much a life as I've seen that. Not to pick on anyone, but well, we all can, but it just takes time and effort and focus. Collectively, when you've got the right tools, what the capabilities are, you can grow with it. And a large part of it is understanding the nature of your system. And if it's topped out and there's limits there, then you may need another layer on top of that possibly. So
Nothing for the rookies to do, driving off to the transmitter site.
Well, if you had this, they would know what to do when they got there. Then I've heard a lot of stories in the past where, and typically when things aren't being monitored at all, they get there and they're just about that far from being off air because of the heating and air's gone out or the transmitter's burning up or, whatever the case may be. But, in a lot of cases where people have tools in place, they haven't taken the time to fully deploy them. I mean, like monitoring power, you would think that's something that needs to be monitored, or the fuel levels of the transmitter. We get some of our best calls when something hasn't been monitored. There's always an opportunity to sell a little bit more if it's nothing but a fuel level kit or a power monitoring sensor or a line level or a line pressure sensor or something like that. So folks, I sure do appreciate your time and attention. I hope this has proved helpful to you.
How long have you guys been doing?
The Sweet Life system, I've been here since 2013. We've been doing monitoring control since about 2002.
Okay.
We started with as Statmon way back when, and we were doing NBC Universal was our first broadcast client. The software itself was born out of Australia, monitoring air to ground beacons with the Australian Air Force, and got connected to NBC Universal way back when, and became their hub monitoring system ever since. And the MNC guys, their history doesn't go far as back, although they've, collectively they've got, I think altogether there's about 45 years of experience between all of us. But they started building out for DirecTV, took over an application that was kind of in place, and then they built that out and took it over. And in 2012, we took over the Statmon software, NFB Consulting did. Then 2013, I joined and we started branding our company Sweet Life Systems, which is how we show up at NAB. And lo and behold, this year at NAB, just before the show, we became Leeward Software when we merged with MNC. So pretty fun story to tell. I got involved with this. I was a systems integrator in Atlanta and ran across an opportunity. Had a client at Intelsat call me needing a time date control of a Panacea router for one of their clients. And the first thing that popped up, my Google search was Statmon. And I called him up and we put in a little control system on a server and replicated the Panacea router on a GUI, and it worked. And from there, we put in big systems at Turner there in Atlanta, and they came and offered me a job in 2013. Rest, you might say, is history. So,
Okay, somebody's got a question on that.
okay. Okay.
Could you talk a little bit about the data logging, like the ability to run reports, historical events?
Yes, sir. Yes, sir. I don't have any screen prints I can share, but every aspect of a device that is connected, all the data is brought into reports, and the reports are programmable to where you can section them off by, functional area. So, all your transmitter FCC logs can be part of one collection. So those are ready to roll if Mr. FCC shows up, and, on down the line. The ability to manage the trends of device performance, especially when it relates to things like IT networks or IP networks as it relates to what we're all installing in the next phase. Being able to manage that bandwidth performance and using that those reports to manage how you're going to make technology changes. And like the one friend I was telling you about, how he used those reports for getting a new UPS. Without that, he probably would have had to wait till it went off the air because working with the GM. But it's clear, concise information that hard to argue with. So, but yeah, that's real critical. Anything that's connected, there's data there, and so the reports are real are real pertinent and relevant and critical. And then the output, of this system, if you've got data visualization tools, Tableau or whatever that might be. There's one that they show in the demo at NAB that I can't think of, but that being if you got you got business ends or data visualization tools, we can output the data from these reports to those kind of tool sets and bring it front and center to that analyst and as needed. And then one thing I didn't talk about was the ability to manage northbound data. And so in many different systems, if the system has a MIB, then it can send the data northbound. Certain monitoring control systems have that. There are some that do not. And it's hard to get data off of those systems because it's kind of proprietary and closed in. But in those cases, if they've got a web interface, we've learned how to scrape the data off of their web page. Just needs to be an HTTPS site where it's secure. Otherwise, if you're sending data northbound, it needs to be SNMP version 3, so it's secure. You got to maintain that. I've got another presentation that perhaps at a later point in time we could come back. My President Nigel Brownick gave at the SBENIS program at NAB before the show began on SNMP as it relates to IP build out environments and that kind of thing. It's a pretty good discussion on the important factors of security and some ideas on how to manage deployments of that. So does that answer? Didn't mean to get long-winded on you. Sorry. Any other questions? Let's see. Oh, great. Nice. Thank you. Appreciate that. All right, folks. Well, that's all I have. I sure do appreciate your time and attention. And it's a pleasure to be here. Appreciate KARE for hosting. Beautiful facility. It's always ah,
Don't forget the sign sheet right there, and I also forgot registration deadline for next month's thing is this coming Thursday. It'll be at 100.
I'm gonna end the